We're now talking about misspecification of functional form. Okay, if either the x variable, one of the x variables, or the y variable should be in a different functional form, should be in logarithms or in a certain power, then we say that the functional form of the regression is misspecified. So let's assume that the true population regression model is y equals the intercept times a slope times the x1 plus a slope times the square of the x. Okay. A case in which this is a valid model would be if you have diminishing returns to scale. Then the beta 2 would be negative, and you would have this concave relationship among x and y. Okay. Just an example. So let's assume that we did not have data for x squared in our model. So we only assume a linear model. Okay. So the regression estimate we get is for the simple regression model. So in that regression, the x squared is contained in the error term. So the error term is now the x squared times the slope on x squared plus the unbiased residual, right? And we can apply the omitted variable bias formula to find the size of the bias, and this is our estimate for beta 1, which is the effect of one extra unit of x on the y variable, which is the true value, which is equal to the true value plus this bias, this omitted variable bias. And well, the covariance between a variable and its squared is very unlikely to be zero. So we say that it's never zero. So and the variance of x1 is always positive, right? So if this x squared variable actually is an omitted variable, which means that the beta 2 coefficient is non-zero, then we have an inconsistent estimate of the beta 1 slope, the effect of a change in x on or associated with a change in y. And furthermore, it's the case that even though you have a lot of data, this bias does not go away. You just minimize the dispersion around the wrong number. Okay, so the functional form misspecification can actually be thought of as a omitted variable bias, as we talked about in the previous video. And the omitted variable are actually the terms that capture the nonlinearities. And this case is, what was I going to say? And what you actually get is a wrong number, and you believe it's the correct number if you do not know that there is a functional form misspecification here. Okay, so how do we solve it? There is no clear-cut method, but you should always use economic intuition to choose the appropriate functional form. For example, as we mentioned, if you have decreasing returns to x1, which means that for higher levels of, for example, production, one more unit of input creates diminishing amounts of output. Okay, so then if you have decreasing returns to x, to production, then you should ask the x squared, or use a logarithmic transform of the x. And furthermore, it's important to look at scatter plots to visualize the relationship between x and y, to see if it's nonlinear. You can also check for possible nonlinearities by adding polynomial terms to the regression, like x to the second or x to the third, and testing their significance, either for single variables or jointly. And we should mention that whenever you create or run the analysis, then you should also plot u versus x and y. Okay, so see you next time.